Welcome back to another Daishinfinity video. In this video, we're going to prove the addition theorem of cosine, which states that the cosine of alpha plus beta, where alpha and beta are all angles, or we can just take normal numbers, are equal to cosine alpha cosine beta minus sine alpha sine beta. So in this video, we're going to prove this formula by using exponential functions. Before we dive right in, we have to define what cosine is. A cosine function is an even function, which means that if I plug in negative values for x, you can just equal it to the positive value. And since it's an even function, you can use the Euler's identity formula, which states that e to the I theta is equal to cosine theta plus I sine theta. You can use this formula to represent cosine of theta. Now, this is the complex function. So we have the function e to the I theta is element of the complex plane. But we would like to represent cosine of theta by using the complex exponential function. Now, how can we do it? Now we know that there's a formula that states that every function f of x can be given by giving the by taking the even function and the odd function and adding them both up, because since we have f of x plus f of x, we have 2f of x, but divide by 2 is f of x, and f of minus x minus f of minus x is equal to 0. So this is equal to f of x. So this is a valid equation. And since this is an even function, this should be the cosine function, and this should be the sine function. So if we plug in f of x inside, then we would have that the cosine of theta is equal to e to the I theta plus e to the negative I theta over 2. Or in other words, when we want to use alpha and beta for our function, then cosine alpha plus beta would be equal to 1/2 times e to the I alpha plus beta plus e to the negative I alpha plus beta. Now, since we have this, we can use our definition again for the exponential function to expand this as a whole. So we would have something like 1/2 cosine alpha we would have cosine alpha plus I sine alpha. And since e to the I alpha plus beta is equal to e to the I alpha times e to the I beta, we can use cosine beta here plus I sine beta. And then we can add e to the negative I alpha, e to the negative I beta. So this will be equal to cosine alpha minus I sine alpha and cosine beta minus I sine beta. Now, since we have this, we can expand those fractions, those parentheses. So we would have 1/2 times cosine alpha cosine beta plus cosine alpha I cosine alpha sine, I plus I cosine alpha sine beta plus I sine alpha cosine beta. I times I is -1, so negative sine alpha sine beta. And then we add a big plus here. This is our plus. And then we have cosine alpha cosine beta, cosine alpha cosine beta. Then minus I sine beta cosine alpha. Then I sine alpha then minus I sine alpha cosine beta, and then minus is plus, and then I times I is minus, so minus times minus is plus, and then again, so we would have a minus again, so minus I sine alpha sine beta. Now what we can see is that all the i's will cancel out. So we have I cosine alpha sine beta, that is this thing, and then we have I sine alpha cosine beta, which is this thing, and then we have, yeah, that's all. So we can combine those, sine alpha sine beta, cosine alpha cosine beta, cosine alpha cosine beta, and then divide all by 2. So we would get 1/2 2 cosine alpha cosine beta minus 2 sine alpha sine beta, cancelling the 2, and then we will have the identity that cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. I hope you liked this video. Please like and subscribe, and if you liked it, please comment, and we will see us next in the next Daishinfinity video. See ya.